Welcome. This video is on symmetry and even and odd functions. Alright, so let's look at this graph that we have on the top. It's a parabola, and this parabola is said to be symmetric with respect to the y-axis. In other words, the y-axis acts as a line of symmetry for the graph. Each half of the graph is a mirror image of the other half through the y-axis. So if you take any point on one side and go directly to the y-axis and then keep going the same distance, you'll get another point on the other side. Or if you fold your paper, so think about that graph. If it's on a piece of paper, if you fold it where the y-axis is, it would be the same thing on the other side. You get the same imprint. Okay, that's called y-axis symmetry. And this next one is called x-axis symmetry, the one below. This is also a parabola, and it's said to be symmetric with respect to the x-axis. And so in this case, the x-axis is the line of symmetry. The one above the y-axis was the line of symmetry. And again, each half is a mirror image of the other half. All right. Also, just note that the graph on the bottom that has x-axis symmetry is not a function. Remember, a function, a vertical line has to be able to only intersect it once. If it intersects it more than once, it's not a function. So the graph on the bottom is not a function. Okay, one more type of symmetry, and that's called origin symmetry. The origin is the point 0, 0, where the two axes intersect. Okay, so here's an example of one. This graph is symmetric with respect to the origin. So if you take any point on one side and then draw a straight line to the origin and then keep going the same direction in the opposite direction, then you'll get a point on the other side. So each half of this graph is a mirror image of the other half through the origin. So three types of symmetries: x-axis, y-axis, and origin. Now, not all graphs have symmetry, and some may have more than one type of symmetry. Some might have all three symmetries. Okay, so what we're going to do is we're going to talk about how to see if an equation has symmetry, whether or not it has these symmetries. And that would help us to draw some different kinds of graphs that we're going to be seeing in the future. Okay, here are the three tests that we're going to use. For symmetry, we have y-axis, x-axis, and origin. So three different tests. And the first one is y-axis symmetry. And what it's saying is that the graph of an equation is symmetric with respect to the y-axis if replacing x with negative x results in an equivalent equation. So if you could replace the x with negative x and do any algebra that you can to make it come out to the same equation, then it's symmetric to this with respect to the y-axis. Okay, x-axis symmetry, it's almost the same thing. This time we replace y with negative y. And the last one is origin symmetry. And this one, you got to replace both of them, x with negative x and y with negative y. And again, if it could equal the same thing as what we started with, then it's symmetric with respect to the origin. If we can't get it to equal the same thing that we started with, then it's not symmetric with respect to the origin or one of the others. All right, let's do some examples. Here's our first one. Determine the type or types, it could be more than one, of symmetry exhibited by the graph of y equals x squared plus 3. All right, so first one, let's replace x with negative x. Does it remain the same? So write down the equation and replace the x with negative x. Okay, now we have negative x squared. What happens when you square a negative? Right, you lose a negative, so that becomes y equals x squared plus 3. Is that the same equation that we started with? It is. So that means it's symmetric with respect to the y-axis. It's always the opposite letter. So if you replace x with negative x and it works out, y-axis. If you replace y with negative y and it works out, x-axis. And then when you do both, then it's origin. All right, second test. Now we're going to replace y with negative y. All right, so we have negative y equals x cubed plus, x squared plus 3. Is that the same as the original equation? No. What if I multiply both sides by negative 1? I could get the y to be positive, but I'm going to change the other side and it'll be negative x squared minus 3. So there's no way to make this the original equation. Therefore, it's not symmetric with respect to the x-axis. All right, let's do the third test. So each of these problems, there are 3 tests to do. So if this was a question on an exam, you have to show each one whether they work or not, unless it was a multiple choice test. All right, so here we are. We changed y with negative y and x with negative x. Now again, the negative x squared, we're going to lose that negative. That's going to become positive. But the negative in front of the y stays there. That's not going to be the same equation, so therefore it's not symmetric with respect to the origin. So this one, we did all 3 tests, and it was only symmetric to the y-axis, not the x-axis and not the origin. All right, very similar problem. Let's do it. First, replace x with negative x. Negative x times y, well, that's just negative xy. Is that the same? No. Not symmetric. Y with negative y? Same? No. Again, not symmetric. Let's do both. Negative x times negative y. What happens to the 2 negatives? Right. We get a positive. Is that the same? Yes. This one is symmetric to the origin. So only symmetric to the origin. Okay, so just be careful when you do these. Sometimes you could get symmetry to all 3 of them. Like a circle centered at the origin, for instance. That would have symmetry to the x-axis, y-axis, and origin. So usually it's just one. Sometimes it could be all three. All right, let's move on. Our next topic is even and odd functions. So first of all, we're talking about functions. In other words, it has to start out f of x equals. That's how you know something is a function, if it's f of x equals. Also, consider that a function must pass the vertical line test. So therefore, a function cannot be symmetric with respect to the x-axis. However, a function can still be symmetric with respect to the y-axis and the origin. So we're going to talk about even and odd functions, and there's only two types of symmetry that we could have. Symmetry to the y-axis and symmetry to the origin. Okay, we cannot have a function that is symmetric to the x-axis. So that's why we only have two tests, so to speak, or two types of these functions. We only have even functions and odd functions. And an even function, this is a function that is symmetric with respect to the y-axis. And the test is if f of negative x equals f of x, then it's an even function. So what that's saying is, if you replace x with negative x and it comes out to be the same thing, then it's an even function. An odd function, odd functions are symmetric with respect to the origin. And this is saying that if f of negative x equals negative f of x, then it's an odd function. So what that's saying is, if you replace x with negative x, and you get almost the same thing except a negative in front of the whole function, then it's an odd function. I know, a little tricky, but we'll do some examples. Okay, here's our first one. We want to determine if it's even, odd, or neither. Neither means it's not even or odd. Okay, so the first thing is, we're going to replace x with negative x. So f of negative x equals 4 times negative x to the third minus 2 times negative x. Now let's try to simplify it. Negative x to the third. That's negative x times negative x times negative x. There's three negatives. So if you have three negatives, there remains a negative. And what we'll do is we'll put the negative in front of the 4. And then negative 2 times negative x, that turns into a positive. So this simplifies to negative 4x cubed plus 2x. So is it the same as what we started? No. So we know it's not even. Our only hope is to see if we could factor out a negative so that we get a negative in front of the same function. So factor out a negative on the right. I know we could factor out a negative 2, actually a negative 2x, but we don't want to do that. We just want to factor out the negative. So if you divide each of those terms by negative, each sign will change inside the parentheses. That's what we get, negative 4x cubed minus 2x. Now, that inside the parentheses, is that the same as what we started with? Yeah, that matches, right? So that's negative f of x. Therefore, this is an odd function. If it's odd, that means it's symmetric with respect to the origin. So if you're graphing this, you know that it's got to be the same on both sides of the origin. Okay, our next graph. F of x equals 5x to the fourth minus 8. Again, same thing, we're going to replace x with negative x. Find f of negative x. So we replace the x with negative x, that gives us 5 times negative x to the fourth minus 8. Now we have a negative x to the fourth power, there's 4 negatives. What happens to the negative? Right, turns to a positive. So is that the same as what we started with, or do we need to factor out a negative? No, that's the same as what we started with. That is f of x. So therefore, this is an even function. It's an even function, so therefore it's symmetric with respect to the y-axis. So each side of the y-axis is exactly the same. If you graph one side of the y-axis, then you know what the other side is going to look like. All right, here's our next one. This is called a rational function. It's called rational because it's a fraction. The word rational has the word ratio. Okay, let's replace x with negative x. So 2 times negative x over negative x squared minus 5. On the top, we do not lose a negative, but on the denominator, we do lose a negative because negative x squared is going to be positive x squared. Okay, so we got negative 2x over x squared minus 5. It's not quite the same as our original function. It's that negative in front. The negative in front of the numerator. Now, what we do know about fractions is if we have a negative in front of just a single term on the top or the bottom, we could move that negative to the middle of the fraction. So we're going to move that negative in front of the 2x to the middle of the fraction. Now it's easier to recognize. Is that the same as the original? Yeah, almost, except for that negative. But we could replace the 2x over x squared minus 5 with f of x. So we have f of negative x equals negative f of x. Therefore, it's odd. So this graph is symmetric with respect to the origin. When we're graphing it, then we'll take that into consideration when we graph it. All right, last example here. X squared over x plus 3. Odd, even, or neither. Okay, let's replace it. X with negative x. On the top, we're going to lose the negative. On the bottom, it's going to stay. Okay, so it's not quite the same as what we started with. We have that negative in the bottom. Can we do what we did last time? Can we factor out that negative in the denominator? Yeah, we could factor it out. Although it changed the 3 to a negative 3, we can still move the negative to the middle of the fraction. Once you have factored out the negative, then you can move it to the middle. But the problem is that it changed the sign of the 3 to a negative. So it's close, but it's not the same as the original function. So this one is neither. Okay, thanks for watching. Wasn't too bad, right? This was a short video. I'll see you here for the next one.